Hi, I'm Callie Stoskop, and I am a site reliability engineer. This is the Deploy in Public workshop. Each week, we deploy a new application that's a little bit more complicated than the one before. This week is Challenge 4. We're to deploy a simple API that we build with NestJS. Just as one route says hello world. That's all. And we're going to use Docker in order to deploy it into two availability zones on two different EC2 instances. Then we'll have an application load balancer in front of everything to balance the load and direct our traffic. If that sounds fun to you, keep watching. If you want to rewind and go ahead all the way back up to challenge 1, otherwise, enjoy your day and thanks for watching.
All right, I am going to create a new repository because this week we're going to start using our own code and we're going to deploy our own code, which is what you really want to be able to do. We're going to use our infrastructure from the previous week and make the edits that we need and deploy a very simple NestJS API. Let's get started. I'm going to create a new repository on GitHub. I'll call it Deploy in Public Simple API. All right, we'll make it public. Sure, let's add a README and let's create this repository. Perfect. Now we have a repository. So I am going to go to my command line here. I'm going to get the address so I can clone it. And I will type git clone and then I will paste in the repository, which I don't know why when I copy a link it does this. If anyone wants to figure this out for me, that would be great. All right, so now we're cloning that into a folder. So now we can go ahead and go cd dip simple API. Now we're in that folder, and then we can do code dot to open a VS Code window with our simple API in it. All right. Now it's just an empty repository, so that's okay. And I'm going to kind of move my windows around now so I can see both at once. All right, so I'm going to use NestJS to make this API. That way, if you are running the same, if you're doing both of my workshops, if you're doing the build in public workshop and the deploy in public workshop, you'll be able to deploy the application that you built in the other one. All right. So in order to get started, you just have to go to your terminal. You have to install NestJS CLI globally, which I already have. So we're going to write nest new and then the project name, which I am just going to write DIP because I'm actually going to take it out of the folder. It's going to create a folder called DIP with all of the files in it. I don't actually love that structure, so I'm going to take them out once the installation is done, so that way it's just in my DIP simple API repo. So we'll just wait for that to run, but basically it's setting up our API for us, and then you can see that we have the commands, which is going to be npm install, which will install all of the packages that we need, and then npm run start, which will start our API. All right, so what I'm going to do is I'm going to take all of this and I'm going to move it into the main folder. I'm replacing my README because that's perfectly fine. And then we have this empty folder DIP, which we can then delete. All right. So I see I have no modules, which tells me that they installed, they already ran npm install for me, but I'm just going to do it just for fun. And then I'm going to run npm run start. All right. And you can see this is what it looks like when my application starts. Okay. Let's kind of go through and look at what's happening. You don't need to fully understand Nest.js. You don't really need to fully understand everything that's going on, but it does help to debug your deployments if you understand the application that's running. But you can always hunt it down as you go. So basically, we're creating an app and we're creating a server basically, and we're saying that this server needs to listen on port 3000. All right. Then we're creating our routes. Okay. So we're creating a Git route here. That's just going to be the git slash, and you can see that right here. We mapped this git route, which is just the index route. All right. And it's going to call this function, the app service get hello function, which if we go to app service, you'll see just returns the string hello world. All right. So essentially what we're doing is we started a server. All right. We have a route that's just the index route. So if I go to localhost 3000 and I just go to that slash, right, and then click enter, you're going to see that we see that hello world. All right. So when we deploy this application, this is what we want to see, but not on localhost. We want to see it deployed. All right. So now that we understand a little bit what's happening, all right, what I'm going to do is I'm going to go ahead and turn my server off, and I'm going to push my code to GitHub. All right. So I'm going to say git status. All right. This is going to be the status of my files. All right. I got rid of the README because I put a new one in there, and then I put all of these files in there. All right. So I'm going to say, yep, I'm going to add all of that to Git, and then I'm going to commit it. And I'm going to say added NestJS server. All right. And then I'm going to say git push to push my code up to GitHub. If I refresh my page over here, you will see now that my NestJS server is up on my GitHub. All right. So now we are going to use Terraform to provision our infrastructure. And then we're going to do it the old-fashioned way, where we actually clone our Git repo or our GitHub repo and manually set up our simple API. We're going to run through the same steps that we do locally, but we're going to do that on a virtual instance instead in the cloud. All right, but that's all deploying is. All you're doing is take your application code and you're putting it in the cloud on a computer that's not near you. All right, but to do this, we need to make some edits, because if you look at our simple API, you can see that it's not running on port 80 like Nginx, but it's running on port 3000. So we'll have to make a few edits as to what we want. In terms of VPC, that's fine. We'll still want the same availability zones, subnets, route tables, gateways, etc. Okay. So the next thing that we want to look at is the AWS security group. All right, and its ingress and egress rules for our private security group. So this is where our private instances are going to be on. Okay. So first, we're setting up a private security group. I don't see anything that needs to be changed. The next thing that we are looking at is our ingress rule. So this is the traffic that we're allowing into our private instance that our application will accept. So accept or allow TCP traffic from load balancer is the name. Okay. So we want to allow traffic, but we don't want to allow traffic on port 80. We want to allow traffic on port 3000, because that is the port that our application is running on. So that's what the port that we're going to want to ping in order to see our hello world response from our index route. All right. So we're going to say allow TCP traffic from the load balancer on port 3000. All right. Egress, we will use the same as before, and I'm going to get rid of the 2 because that doesn't really make sense. It's an egress rule. So we're going to allow all traffic for our private instance out of our instance. All right. Now, the next thing that we're doing is provisioning the actual private instance, which will use that security group. Okay, so everything looks good. We still want to do 2. We still want it to be in the subnets in our VPC that are private. Sorry, I'm drinking coffee as I'm talking to you. We still don't want public IP addresses, and we still want to use our private security group that we just edited. Yep, we still want our EC2 instance profile attached. But this time, we don't want to apply our script, right? Because if you look at our script, we're installing Nginx. But at this point, we don't want to install and change the HTML page and start Nginx. We don't need to do that anymore, because we want to go in and manually install and run our application. All right, so we're not going to use the user data field. All right, let's keep going. So now we want our EC2 instances to have this IAM role. And the policy that we want to attach to that role is the SSM managed instance core. That's correct still. All right. Our load balancer security group is next with an ingress and egress rule. All right. So we are saying here that we want to create the load balancer security group. That's fine. All right. And then ingress, we want to allow TCP traffic into our load balancer. All right, I'm a little bit confused about the ports here. I'm thinking 80 is fine, but I'm actually going to ask Copilot to help me explain exactly what this rule is saying, so that way I have a good understanding and I can make a decision about whether or not I change the port here. All right. The from port 80 and to port 80 lines are specifying the port range for which this rule applies. In this case, it's a single point, port 80. In summary, this code is creating an ingress rule that allows TCP traffic on port 80 from any IP address to the resources associated with load balancer security group. All right. So my initial inclination is that I want to keep this to port 80 because this is the traffic that's coming in to the load balancer, and I want that to be any port or any IP address at port 80 because that's the port that HTTP traffic travels over. But if we're wrong, and we will go ahead and fix it. All right. The next one is going to be our security group egress for our load balancer, and that makes sense. We want all egress traffic. I, again, don't think this 2 makes sense, so I'm going to go ahead and get rid of that for readability. All right, so now that we have the load balancer security group, we're actually going to create the load balancer. I don't see anything needing to change here, but now we have our target group. Okay, so let's go through and make sure we understand what's happening with our load balancer. So first, we have our load balancer listener. It's listening on port 80 because that is the port that HTTP traffic goes over, and then we are going to forward that traffic to our target group. Okay, we're forwarding that traffic to our target group at the port 3000. All right, and our attachment, the group attachment that we're attaching to this target group are going to be our 2 private instances that run on port 3000. All right. So then what we can do here is we can go ahead and highlight the entire load balancer and click explain this to make sure we understand everything that's going on. So as it's thinking, I'm pretty sure I'm doing good. So I'm actually going to start with Terraform apply. We'll let GitHub Copilot think, and we'll start provisioning our resources. And if we got something wrong, we'll just edit and re-provision. All right. So this is setting up our application load balancer. All right, so this first block is creating the load balancer, and it's using the security group from the load balancer security group. The target group block is creating a target group for the load balancer. Port is set to 3000, specifying the port on which targets receive traffic, and that's perfect. Our targets are our private instances, and those will have our NestJS application running on it, which runs on port 3000. So that is the port we want to send traffic to. All right, the resource attachment block is registering targets with the target group. It's registering 2 instances to the target group on port 3000. All right, so in summary, this code is creating an internet-facing ALB that listens on port 80 and forwards HTTP requests to 2 instances on port 3000. All right, that sounds like exactly what we want to do. So I am going to go ahead and let these AWS resources provision, And I will pause and then play once they're done provisioning. All right, my resources are all provisioned. So let's go ahead and take a look and make sure that we can access them with Sessions Manager. All right, so I have one load balancer, that's good, and 2 instances. Let's go ahead and take a look. So we have our private EC2 1 and private EC2 2. So if I go to connect, I see that Sessions Manager is going to work. I can either click this button connect here, I can go to the Session Manager's page, or I can use AWS CLI. So what I want to do is I want to do AWS SSM at CLI. And we can go look at nope, it's not the right one, how to start a session using your terminal. All right. So you can use AWS SSM start session and then use the flag target with your instance ID. So let's go ahead and make sure that we can SSM, use Sessions Manager to get into each of our instances before we end this video. All right, so I'm going to say AWS. I already forgot what it is. SSM, start session, and then target. And you can see that we're able to start our session. All right. So the second one's set up the same. I'll allow you to double check that that's right. All right. Now that we can get into our instance, let's go ahead and try to clone our repo down. All right, so I'm going to close out of this tab because we are into our instance. All right, and for context, I'm in my EC2 instance 1. All right, so now any other time I would be working on a computer and want to get code up and running, I would go to GitHub and then I'd click this code button and I'd get the URL, and then I type in git clone and then URL. On my local computer, this would work. But on this private instance in the cloud somewhere, I get the error git command not found. Now, that error is pretty familiar, and the reason why it's familiar is because when you get this error, it just means that the command's not found because git is not installed on this computer. All right, and by this computer, I mean the computer that I'm deploying my application to in the cloud. So what do we need to do? We need to configure and install Git. All right, so here's how you do it. Sudo yum update -y. You don't really have to do this one, but basically this is just making sure that all of the packages that are already on this computer are updated, and the -y flag answers yes to any prompts that it encounters while it's updating its packages. All right, the next one now is to actually install Git. So you can say sudo yum install Git, and then again the -y, so that way we click yes when it encounters any prompts. All right, now Git is installed. So we could run git clone to try it again, but a good way to test whether or not what you just installed actually installed is to type in the name of the package that you just tried to install and then -- version. And if you get a version number, then you know that you've installed it and you can see what number you installed. So now I can go to my git clone and I get fatal could not create work tree dir DIP simple API permission denied. So permission denied usually makes me think that I don't have the right permissions to do what I'm trying to do on this computer, right? That's why we use sudo when we're before anything, is because we're trying to use it as the root user. All right. So I went ahead and opened over here. I found this error that someone else had, which is the same error. And when they were trying to clone a repo, all right. And it just basically says that the issue is we're working in a directory on this computer that we do not have write permission to. But what we can do is either give myself the ability to use that directory, right, by changing the permissions, or by just going into a new directory. Okay, so that's what I'm going to do. I'm going to first cd into the root folder. All right, and I'm going to say make dir, which is make directory. We're making a folder. Sure, we can call it code. Then we're going to get into code. And now we're going to try our git clone. All right. And because we're in a directory that now we can use, you can see that we get our normal response when we use git clone. All right, if I say ls, it's going to show me that now I have this DIP simple API folder in there. All right, so if I then cd into it, all right, you can see all of my files, which is pretty exciting. All right, so now you have to think through what's the next thing that I would do if I was trying to run my API. And the next thing is that I would do npm install. So let's go ahead and give that a try. Ah, dang. And we got npm command not found. All right. In order to use npm, you need to be using Node. All right. So what's happening here is that the Linux computer is just saying, hey, you don't have Node. So here is a tutorial that I bookmarked now that shows you how to get Node. All right. So basically, you can make this curl request. I will let you go through and read all of it. All right. Then we're going to just follow all of the commands here. All right. We will install the latest version. All right. And then we can finally run this to just show us what version we're running of Node. You can see that this printed out. So we are all good to go. So now what we can do is we can try npm install and see what happens. And you can already see that things are happening a little bit differently. And this looks very similar to what happens when you are locally running npm install. Now, warn deprecated is not optimal. We should probably look into it at some point, but no errors. We're good to go. All right, so now we went ahead and installed all of the dependencies that we needed. So now, just like we do locally, we can say npm run start. And just like you see locally, you see the log start up saying that it started. All right, so we have now deployed our simple API onto our private instance one. And if you notice, it's not that different than just installing or cloning down a repo locally on your computer and getting it up and running. All right, so this is EC2 1. Let's now go to our load balancer. All right, and take a look and see how that's doing. So I'm going to open this up. All right, so you can see that we're listening on port 80. That means that it's just listening for HTTP traffic coming into the load balancer. And then you can see that we have, once it hits port 80 with an HTTP request, it's then forwarding that traffic to port 3000 on our target group. Now, what is our target group, you ask? Well, our target group is our two private EC2 instances. The issue, however, is that we see that this instance here, we just uploaded our application to, but you can see both of our instances are marked unhealthy. What is happening? Let's go back to our Terraform and take a look. All right, so we're forwarding traffic to our instances. Trying to see where, let me search for. Oh, do we not have a health check? All right. I thought we added the health check code in, but that must have been it. Yeah, it must have been at a different point. So I specifically, in one of my practices, coded in a health check here, but the health check basically is it's going to, let's go over to here. We just did the default because we didn't enter something specific, but basically it's going to make an HTTP request every 5 seconds, right? Timeout 5 seconds. Every 5 seconds, interval 30 seconds, sorry. Every 30 seconds, it's going to make an HTTP request to the traffic port, okay? So basically, at port 3000, we're going to get a request at /. If you look at our instance, you can see that at port 3000, just the / route, that's going to be our hello world route. So what's happening here is our load balancer every 30 seconds is trying to hit this endpoint and is saying, hey, is anybody there? if it gets a success code, a 200 code, that means, yay, this application is working, it's healthy. And that would mean 1 here or 2, which would be what we're looking for. And then it would start sending traffic to it. Okay. So if I go back to my load balancer, let me actually refresh this because it could have been talking long enough that it changed to healthy. Let's go back here. And yeah, all right. So basically every 30 seconds it's hitting it. All right. If you look, it's saying that it needs to have 5 consecutive healthy check successes in order to be healthy. So that's why it took a few minutes for this application to switch to being healthy on this instance. Okay. But now that we have at least one healthy target, then if you go to our application load balancer here and when you take the DNS name, when we hit that DNS name, it should load our hello world response because it should, yep, there we go, hello world. It should come from our application. So now what we can do to check this, to verify, so right, I can refresh. If you remember last week, every time I refreshed, it was switching between my instances. Well, I only have one healthy instance, so it's not switching. All right. You can check that too by going ahead and saying ls, and then we can cd into src, which is the source folder. Then we can go ahead and say nano app.service.ts. All right. And instead of returning hello world, just the string, let's go ahead and change this and let's just say hello world 1. And yep. And then we can go ahead and I'm going to cd out back into that folder and then start my server again. Wait for my logs to come in saying you did it. All right. And then I can go ahead and refresh this. And now I see hello world 1. And if I refresh it, I always see hello world 1. All right. In the next video, we're going to get the instance up and running, the second instance up and running with our application. So stay tuned. All right, now that we have our first instance up and running, I want to clean things up a little bit and I want to like further drill home what's happening. So the first thing that we're going to do is we're going to type in bash remove a folder because we cloned down the folder twice and there's no need for that. So let's try this. So we're going to say remove -rf and then we are going to remove DIP/simple API. So then we're going to try again with sudo. All right. So it's ls, and then let's go look to see if that worked, and it is gone. All right. And yep, I don't see DIP anymore. But if I curl localhost on the port 3000, I still see hello world. All right. So now how can I verify that this is not pinging my second one? Well, first you can verify it because there's nothing on your second instance, but let's go ahead and actually edit a file. Okay. So we can, let's go back here. So we're going to cd to the root directory, and then we're going to ls, we're going to cd into code, and then ls, we're going to cd into DIP simple API, ls, and then we're going to cd into source, or ls, and then we're going to go sudo nano app.service.ts. And that's going to open up our service file where we have return hello world, and then I'm going to just say 1. All right. So now that is edited. Okay, I can curl the local host and make your guess now if it's going to change it. And it did not, and that's because we did not restart our server. So we can go ahead and restart our server. All right. And now that we restarted our server, if we curl localhost, we should see hello world 1. All right. If I reload this page, you can see I see hello world 1. And it doesn't matter how many times I hit it, hello world 1 is the only one that I see. Okay. So I'm going to close that one window. I'll keep this one open, but honestly, it doesn't matter that I keep it open or not because it's running remotely on the cloud. It doesn't matter whether or not, like if I control C, it would stop the server, but if I close out of it, it's not going to do anything. See? All right, so let's go ahead and now we're going to do the same thing, but on our next target on 2. Okay, so let me close out of all of these tabs. And we'll go into our instance, our private instance 2, copy the instance ID and paste it in there. And now we are in our second instance. All right, so let's go ahead and follow our commands that we needed. So we want to install Git on Amazon Linux. So let's go back to this article. Was that this one? Yeah. Silly me. All right, and I can go ahead and sudo yum update -y. Make sure all of my packages are updated. Right, and then I can sudo yum install git -y. Perfect. And then let's check our version to make sure that we installed it properly. And looks like we did. Unknown. Oh, because I spelled version wrong. And there is our Git version. All right, so now we can go ahead and install Node. All right, so we're going to follow these commands now to go and get Node. All right, install the latest version. And then let's make sure it's running by echoing out the latest version, the running version. All right, perfect. So now that we've done that, we can go ahead and get clone. Let's go back to our fatal things. That way we don't do that again. So let's cd into the root directory. And then let's make a folder called code. Let's go into code. And then let's clone down our repo. All right, so now we have our repo, so we can go ahead and cd into it. All right, let's try npm install. Now I'm going to pause and I will come back when it's done. All right, now that we have Node installed and all of our packages are installed on for our application using npm install, we can get things started. I think what I want to do first, though, is I'm going to I'm going to cd into the source folder just so we can do the same thing that we did on the other instance where we change the hello world just so we can get a clear picture of what's going on with all of the pieces of our puzzle. All right, so now we have hello world 2. So now what I can do is npm run start, just like I would do on my local computer to get my project up and running. And then it's going to go ahead and get started. All right, so it's not super instant. So we have to go to our load balancer. Let's open this up. And when we click on our load balancer, we can see our target group. And you can see one is healthy and one is unhealthy. So I'm going to pause here and I will wait until this turns healthy and then we will go ahead and take a look at our results. All right, now both of our targets are healthy. So let's go ahead and use our load balancer. And you can see that now we're toggling between 1 and 2. All right, so the benefits of manual deployment is you're in control of everything. But the bad part is now anytime I want to update my, what's it called? my simple API, I then need to push my code to GitHub, and then I need to get into each of my instances and pull down the changes, restart everything, make sure everything is working as addressed. Okay. Um, so that's not the ultimate goal. We want to automate this a little bit. And our first step towards automation is learning about Docker, which is what we'll learn about in the next video. All right, so I'm going ahead and destroying all of my resources on AWS. And the reason for that is because we already installed a bunch of stuff on them. So I just want to wipe everything. And instead, we're going to look at Docker. Okay. I'm a Mac, so I use Homebrew to install things on it. So I'm going to go ahead and just copy this command here, brew install Docker, and that's going to install Docker, hopefully, on my machine. So that way I can then use it. All right. I'm also going to look up how to install Docker desktop. And that is going to allow me to have an application that I can use on my computer. All right. So let me see what I need to do here. All right. So we want the Mac with Apple Silicon. All right. So it sounds like it's not necessary to install Rosetta, but we might want to. So I'm going to go ahead and just do it anyway. All right. And then I'm going to continue reading. Double click Docker DMG, where okay, to open the installer and then drag the Docker icon to the applications folder. All right, that doesn't seem too bad. So I'm going to just kind of wait until Rosetta 2 is installed. You can see that I have installed Docker 3 times. All right, let's replace my old Docker. I thought I uninstalled and deleted it right, but I probably didn't drag the actual app to the trash can properly. So hopefully this is downloading and getting us the correct version of Docker. All right. Can I open it now? Let us see. Ooh, we're verifying Docker. Feeling good about this. Yes, I'm sure I want to open it. I accept. I will use the recommended settings and I will. All right. I already have an account with Docker, so I'm going to just do, can I continue with Google? But go ahead and if you don't have an account with Docker, I am a site reliability engineer. I'm going to skip the survey though. Let's be real. All right. So here is Docker Desktop. When I have running containers, it will go ahead and show there. I'm going to drag this to a different window because it's not super necessary for me to have right now. And I am going to close my Terraform. Actually, I'm going to close my Terraform because we don't need that for a while. I'm going to open up my simple API and I am going to create a Docker file. Now, what is a Docker file? A Docker file is a list of instructions that you are going to give Docker, and then Docker will complete those instructions for you. And the benefit is that they use layers to layer one thing on top of the other. And you can use layers from Docker's registry. So that way you don't have to install everything yourself and you end up with a smaller sized application, which hopefully runs faster. And because you're using these different layers, you are not going to have as many differences in terms of, well, it works on my computer, but does it work on their computer? It's a little bit more consistent. All right. So what we are going to do is we're going to create those list of instructions. So what we need first is a Docker file. All right. So this Docker file is where we have our instructions. All right. So let's go ahead and type in Docker file for NestJS application. All right. I already have one bookmarked that I like. So the first thing we need to do, install Docker, check. We did that. And the next thing is that we are going to create our Docker file. All right, so let's go ahead and I'm going to just copy this and then we'll go through line by line to better understand. All right, so the base image from node 18. All right, I'm going to use GitHub Copilot here and I am going to have it explain what this means. But essentially, we are going to be using the image node 18 to run our application on. All right. The from instruction initializes a new build stage and sets the base image for subsequent instructions. In this case, the base image is Node 18. All right, it's a Docker image that comes pre-installed with Node.js. All right, so using this from Node 18 means that we don't have to go do that curl request and go get Node and download it, set the latest version, and do all of that. We're going to just use the image that already has it installed on it from Docker Hub, okay? Which is a registry that allows you to link to code repositories, build your images, test them, and store them, okay? So this is going to be the foundation of our Docker image. Then everything else builds on top of it. So we're using Node, that's our base. From there, we're going to build on it. All right, next line, create an app directory. So sure, we can have Copilot explain this, but essentially what you're doing is now you're in the file system, you're creating a directory that you're going to use to then put your app and do everything that you want to do with it. We call that the working directory. All right, it sets a specific directory in the Docker image that will be used for all the subsequent instructions. Okay, I feel like user source app is a lot, so I'm just going to make my working directory /app. All right, so you can see here that any subsequent instructions that will be run from this directory. If the directory doesn't exist, Docker creates it for us. So this is the same thing as saying make directory and then where we're at, what directory we want. Okay. So the next thing that we're doing is we're using the copy line. Okay. So the copy line, you have like two arguments for it. The first is what you are copying. And then the second is where you're copying it to. Okay. So we are saying that from this file structure here, because we're building an image, right? So we're building our image and we're saying our working directory in this image that we're building is the folder app. Okay. Then what we want to do is we want to copy the package lock JSON and the package JSON, and we want to put them into our working directory, which is that /. We want to put it into our app. Okay. Then we want to run npm install. That's just like what we did, right? So essentially this is copying over our package JSON. So when you npm install, what that's doing is it's going and reading your package JSON and it's looking at all of the dependencies that you need and then it's installing it. Okay. So here's all of our dependencies and our dev dependencies and they're getting installed. This little star means that we want anything that starts with package and then ends with .json. And then anything in between we want to include. So we want to include the package JSON too. All right. We can GitHub Copilot that if we want, get a better explanation than what I gave, or maybe a more complete, who knows? Yep. So it copies everything from the source directory that you tell it to copy. Yep. Anything that starts the package ends with .json, and then it's copies it into the current directory in the Docker image, which is /app. All right. So then npm install is what's going to create this folder node modules for us. Okay, so that's pretty good. And then what do we do here? We have another copy statement. So remember, there's two arguments for it. The first is what we're copying from, and then the next is what we're copying to. So here we're copying everything out, everything that's in the folder that we're in, so all of this, and then we're copying it to our working directory. Okay, so after we install the dependencies, then we're copying the rest of our application files. All right, so here's going to copy over all of our env. We don't have any env files right now, so I'm going to just go ahead and get rid of that line. All right, the next is going to be a little bit of a deviation from what we do locally / what we just did on our EC2 instances, okay? We just installed and then started up the server, all right? But in production, you want to do a production build instead. All right, so how do we do this? Well, we have to build our application first by running the command run npm run build. What that does is it creates this dist folder here, all right, and compiles everything into JavaScript, all right, from TypeScript. All right, then we expose the port that we will have the app running on, which is going to be port 3000. This honestly is more for a readability standpoint than it is of like, it's not doing anything. It's just when we read it, we know it's not running on port 3000. All right. And then we start our server using the production build. All right, which is from dist. How do we know what that's doing? Well, you can go to your package JSON to see your different scripts. So if we go up to our scripts, you can see that npm run start prod is really running node dist /main. So what does that mean? When you say node, you're telling node, run the application, run the code that's in whatever file I'm giving you. So it's saying run the code that's in the dist folder, so that's the dist folder, and then the main file, which is our main application. It's just saying start up our main application from that build that you just did. All right, so this is our Docker file. Now, we have one more thing to add, and that is this, yep, thank you, -- platform equals, and then what we want to do is we want to say Linux / AMD 64. That is if we are building this image on our Amazon Linux machine. All right, right now we aren't, we're just going to locally build it. So I'm going to get rid of it, but just keep in mind that we will need it in the future or we're going to have an error. If you're coming and having this error that's really confusing and it's like it can't build, like you could build it locally, but you can't build it in the cloud, that's what it's likely talking about. All right, so now how do we build a Docker image? Well, the next thing that we do is Docker build, and then we're going to tag it with a name, and then we're going to say what folder we want to build from. The next thing, though, I do want to do beforehand is I don't have a Docker ignore, so I'm going to just go ahead and get a Docker ignore file. Bum, ba-dum, bum, bum. So Docker ignore is like git ignore, okay? And it's going to tell you what to ignore. So you can see here that we're copying all the files over. Well, part of that is our node modules. So it's going to copy our node modules too. And we don't really want that. So what I'm going to do is I'm going to create a file and I'm going to call it docker -ignore. And then I am going to find a Docker ignore file. Oh, wait, do I not do docker -ignore? Silly me. Okay, there, that's a Docker ignore file. Do a little Docker. So yep, you don't want to copy extra images, extra things that you don't need. I'm just trying to find like a good example one. So we want to ignore, that is good, the Git folder. We want to ignore the Docker file and the wildcards for start and finish. And we want to ignore the node modules. All right, so that should be good. Okay, so now we can go back to here and we first want to build it using Docker. All right, so we have our Docker running, good to know. So now we can say Docker build -t, and then we're going to say simple API, and then the dot just means that we are building from the folder that we're in. So if you're in a different folder in your terminal, then and there's no Docker file in that terminal, then you're going to have errors here, which we might have errors there anyway. All right. All right, so it is building. It's asking for my password. I hope I get that right. All right. And so that's going to go ahead and build. I'm going to pause it because it takes a while to build, and then we will continue after it finishes. All right, so we finished building. All right, so now we're going to use the next command, which is going to be Docker run. So we're going to say Docker run. The --rm means to run it in the background, and then -p 3000. Wait, actually, what does it mean? I don't think I'm getting that right. Docker, what does that mean? Oh, so 5 Docker commands you need to know. You can tell that I don't use Docker commands very frequently. So Docker means remove. So I'm guessing it means that I'm removing the Docker container as soon as I start it, which makes sense. Okay. So port 3000, we're mapping it to port 3000. So -p is the port flag. So we're saying that the Docker container, so like I'm going to hit port 3000 on my computer that it's running, my Docker container is running on, and then that's going to forward my request to the port 3000 on the container. And then I need to make the name of the container. And now you can see that it is running. Okay. So if I go to localhost 3000, you can see that I have my hello world. Now that we can locally build and run a Docker image, it's time to switch things up. So what I went ahead and did is I destroyed all my resources that were on AWS, and I re-added them. So I have all of the resources from when we manually deployed our GitHub repo. All right, but we're going to minimize that for now, and we will pull up our simple API. All right, because what we want to do here is we want to run our Docker image, we'll build our Docker image, and then run that Docker image in our EC2 instances, okay? But very rarely, if ever, at work, are you going to be allowed to push a Docker image that you have for a work application to a public registry and then just pull it down from Docker whenever you want. All right. More likely is that you are going to have to use a private registry and then push to that and then pull from that and build your Docker image. Okay, so I am going to show you how to use Amazon Elastic Container Registry, and we're going to start manually with it and get it set up before we do anything with Terraform. Okay. So here's what we do. We are going to create a repository. So what is a repository? It's just going to be a place where we can put our Docker image that then we can communicate with from our EC2 image, our EC2 instance. Because when we went ahead and built our Docker file, right, locally, we then ran it locally and it was running off of our Docker on our computer. All right. But we can't do that from the EC2 instance because how would it communicate with our personal Docker? It can't. Okay, so instead, what we need to do is we need to make a private registry in the cloud that only we have access to, and then we can pull our image down and run it. All right, so we want a private visibility. Access is managed by IAM. All right, and then we need to name it. So I'll name it Coding with Kali ECR. All right, and then I'm going to create the repository. Maybe. All right, so now we have a private repository. And the instructions to push are actually super easy. I just open up my repository and then I click View Push Commands. You'll see that this is where all of our images are going to be stored. We don't have any now because we just created an empty repository, but this is how we can go ahead and create a repository and push it to our repository here. So first I'm going to open up my terminal and then I'm going to use this. So the first thing that we need to do is retrieve an authentication token from AWS and authenticate our personal Docker client to use the registry. So that is going to be this. I just go ahead and copy it and paste it in my terminal and press enter. And it is going to log me in to AWS and allow me to use it. Hopefully. We shall wait. You can do it, AWS CLI. There we go. Login succeeded. All right. The next thing that we're going to do is copy this one, which reminds us of the same build command that we used locally, because that's all we're doing. We are building an image and we're naming that image Coding with Kali ECR, and we're building it from this file location. All right. It's going and finding this Docker file, and then it's building the Docker file. Mine went really quick because I just in the last video built the same image, and when you have built an image before, it like caches and it uses those layers. All right, the next thing that we want to do is tag it. So we're going to tag our image with the tag latest, and then we are going to push this image, all right, to our repository. And you can see it is pushing. Yay, yay, yay. All right. And I already think I noticed an error, but we're going to keep going. If anybody catches this in this video and notices what error I think I'm making, let me know. And I don't know, I'll give you some sort of shout out. See if you can guess where our issue is before we head into our gotcha moment. And guess, are we actually going to get to that, or is it going to work out okay? All right, it's taking a long time to push because it's the first time we're pushing, but once it pushes, it's going to go ahead and end up here. So while it's doing that, I am going to head over to EC2 and open that in a new tab. All right, and I'm going to head to my instance. I'm going to copy my instance ID because I want to start a session so I can go ahead and go into it. Okay. Similar to how we needed to download Git and Node in order to clone our repo and get it up and running, in order to run Docker, we need to download Docker and get it up and running, okay? So the first thing that we will do is do the update command, so sudo yum update-y. And I'm not sure if we have if the Linux we're using has the Amazon Linux extras. I'll go ahead and give it a try. Otherwise, we can just do sudo yum install Docker. But let's see, just because I pulled it up. Yeah, so see, that's not found. So let's try sudo yum install Docker, and then we'll pass the Y in there. All right, so that's going ahead and installing. Perfect. And then we can say sudo service Docker start. All right, so our Docker service should have been started. And then I think this log out. Okay, I think this is what this is doing, is allowing it to, like, if I log out from EC2 and then log back in, I should still be able to run Docker. So I'm going to just add that just for funsies. And then let's try doing Docker info. Do I need sudo Docker info until I log back out? Yes. Okay. So let's exit and then let's try again. See, just read the directions, man. All right. So now try Docker info without the sudo, and now it works. Okay. So now Docker is installed and we have it. All right. This is still pushing. Oh my goodness. All right. I will then go ahead and pause here and I will resume when it's done pushing. All right, it finished pushing finally. So now we can go ahead and try to pull it. All right, so here is the image. In case you don't believe me, it's now in our repository. All right, so now we can go ahead and copy the URI. And if you look, all right, you can both build ECR images and you can pull them. So I'm going to try Docker pull, and then I'm going to paste in the URI. And unfortunately, we get this permission issue. So I'm going to go ahead and copy it and see what we come up with. And lo and behold, we have a solution. How do I know it's a solution without even looking at it? Because I bookmarked it because I hit this error earlier. So basically, we do not have the correct permissions. We need to do one more command in order to be able to use Docker. All right. So the next thing error we get now, after we went ahead and added permissions so that way we could use Docker, is we got another error, but this time we have no auth credentials. All right. So now let's look up at this one. And then I'm going to write no basic auth credentials, ECR Docker EC2 instance. All right. And you can see I don't have this one. Looked up yet, but it's because we are not logged in to we're not logged into ECR. So we can try two things. The first thing that we can try is to use the AWS login here. All right. And we get access denied. All right. Because you can see, and this error is actually going to help us better because it's going to show us what the issue is. Basically, it says that our EC2 role that we have, remember that IAM role that we created for our EC2 instance with Terraform? It's saying it's not authorized to perform this. All right. So what we need to do is we need to go over and head over to our role, and we need to add a permission to it so that way it can read our registry. All right. So I'm going to head over to IAM. and I'm going to go to roles. I'm going to get my Coding with Callie EC2 role, and I'm going to edit it. Nope. And we're going to add a permission by adding a policy. I'm going to open this up, and I'm going to type in registry. All right, and you can see that we have a bunch of different accesses that we need. So you just need to think about what your EC2 instance needs, and we just need to be able to read a registry. So we are going to select Amazon EC2 Container Registry Read Only, and this provides read-only access to EC2 Container Registry repositories. And I'm going to add the permission to my IAM role, which I then now have. And I'm not sure if we're going to need to, and now we reran it and you can see login succeeded. So now let's try to pull the image, and we are cooking with gas. We are able to pull our image down. So that's the first step. Now let's go look at the next step. So first we pull our image down, and then we're going to have to run our image. All right. We're getting so close. You can do it, Docker. All right. I need to go find my command that I used. All right, so yeah, here's my Docker run command. I tend to not remember commands and just kind of keep them all in one place, either in bookmarks or my or like notepads and stuff like that. All right. Docker run --rm--p, and then we want it to go from port 3000 to port 3000. And then we want to put in the URI. All right. So if you can see, we have warning, the requested image platform does not match the detected host platform. All right. So the image was built with Linux ARM64 v8, and the platform that we're on, it needs Linux AMD 64 v4. All right. So then we get this exec format error. So basically what this is saying, all right, and let's go check first of all if it ended up running. So we should be able to curl local host at port 3000 if it's working, and it's not connecting because it didn't work because of this error. All right, and if you look up this error, which someone on Stack Overflow has, it's basically saying that it's because I built the image on my MacBook Pro and it is running it on a Linux machine in the cloud. So we need to add this platform Linux AMD 64, which lines up with what the host platform is running. Okay. And you should remember that I said this in a previous video that we would need this when we actually were trying to build and use this image in the cloud. All right, so we'll end the video here, but we'll test out fixing it by rebuilding and redeploying in the next video. All right, now that we fixed the error in our code, all right, we're gonna have to redo the process. And I hope that this is starting to, so first command is to log in, but we should already be logged in. So the second command, sorry, I'm just getting this started just in case it takes a long time before I start soapboxing you. All right, so yep, the next command then is we are going to build our Coding with Callie ECR. I'm gonna let that run and get back on my soapbox. So you can see that this is already getting kind of tiring, that every time we need to make a change to our code, we then need to build our image locally on our computer. Then we need to push that image to our ECR repository that we have. and we need to tag it. Then we need to go and log into our instances and pull the changes and then rerun our Docker container, our image in our Docker container, right? So this is going to get super tiresome. So you should be, if you're already not on board with creating CI/CD pipeline, you should be, because that's what we're going to work on next week. But we're going to kind of finish doing the manual path and finish automating our infrastructure before we set up our GitHub actions. But anywho, we're going to go ahead and keep building this and follow the instructions. I'll go ahead and pause here so you don't have to sit here and watch the timer count. But it will be faster, at least a little bit faster each time you build or the smaller change that you make, because it's caching the layers. All right, shutting up now. All right, so now we can tag our image with the keyword latest, and then we can push to ECR. And you watched it push last time and it took a long time. Now you can see that we're pushing layers that already exist, and it's going a little bit faster than it did before. All right. So I'm trying to see if this will take too long. I'm going to go ahead and pause once again, and then once it's done pushing, I will resume. All right. Still getting pushed. We'll resume in a few. All right. We finished building and pushing our image to our ECR repository. If you go ahead and refresh your page, you shall see that the image tag latest has now moved to our latest image because we retagged it, right? All right, so if we go back to our instance over here, we can go ahead and Docker pull. So that's going to pull our latest down. You can see it's using the default tag because we didn't add a tag at the end. But if you're versioning, you will have the version there instead, right? And you can have multiple tags too. So you might have latest and then version 2, version 3, whatever, 2.00, whatever. You know what I mean? All right, so this is going ahead and pulling down. We are getting close. I think my internet's just extra slow today. All right, perfect. And now we can go ahead and run. Woohoo! And we started our application. All right, so what I'm going to do next is I'm going to open up a new tab. All right, and then I'm going to go to my EC2 service. I'm going to go to my instances, and now I'm going to go to my second instance here, and boo. All right, AWS SSM, I think it was, oof. All right, AWS SSM start session. One day I will remember commands. Start session -- target, and then we'll paste in our target instance ID. So we're started. All right, so now we have to repeat the process in terms of we have to install Docker. So let's find, all right, well, it's going to be sudo yum update -y. And while we're waiting for that, we can actually go to our load balancer, because we should be able to see whether or not our targets are healthy or not. All right, so 2 unhealthy, we will check back. All right, so now we can do sudo yum install docker -y. All right. Then we can do where's our command? So install Docker. All right, so then we want to do sudo service docker start. And then we want to do this command, which will allow us to use Docker from our EC2 users, so we don't have to use sudo. This is going to, I'll also bookmark this one because the other article was like slightly off and we got that error when we used our first instance. I'll bookmark the Stack Overflow, which is another one that helped me get past that error. All right. And then to check that we're all set up, we're going to try Docker version and it works. So now what we can do is we can go back to, well, first let's check our, ooh, now we have one healthy. All right. I'm going to not worry about that though. But that's our first instance, right? We finally started an application. That means it finally got to the point where it was working. All right. So first we need to log in from our EC2 instance. We should be able to do it this time. Login succeeded because this instance also has the same IAM role, the EC2 IAM role. All right. And then we should be able to say Docker pull. And let's go get our URI. We're using the default tag latest again. So it's going to go ahead and pull. You can do it. All right, I'm gonna pause because it's taking a while and I will resume when it's done. All right, now we can go ahead and do our Docker run. What was our command? Just copy it with our port and then, yep, our image. And now it is up and running. All right, so that should mean that both of our targets momentarily will be healthy. So it's going to take a little while to get that one up to healthy, but we should be able to go to our load balancer and get our DNS name and see our application, hopefully, running from our load balancer. And we see our hello world. I will go ahead and pause and wait for the load balancer to say that our other instance is healthy, just so we can check off that we did this one. But we're very close. All right, we have 2 healthy instances in our target group. Now you're not going to see any difference between them, but we are hitting both instances now, and that is very exciting. All right, so I went ahead and destroyed all of my resources because it's time now to automate things a little bit more. Now, before in previous weeks, we used the user data field in order to actually deploy our application. Could we do that here? Well, yes and no. Best practice is that you want to deploy your infrastructure with Terraform, and then you want to use something like GitHub Actions to deploy your actual application. So we are going to provision all of the resources we need and get everything set up for us. And then we are going to manually finish things off this week to set ourselves up for learning how to use GitHub Actions next week. All right. So don't be sad when you finish everything and you're like, oh, well, that's not super fun. And if you want to continue working on your own, I support it. But we want to do things following best practices. Why is that a best practice that we would not use the user data field to deploy our application? Well, we'll actually see why that's an issue as we keep on keeping on. But what happens if you change your code? You don't have to do Terraform destroy and Terraform apply like we're doing right now anytime you want to make a change. You only want to Terraform apply when you change things to your infrastructure. And hopefully you don't have to destroy first. You hopefully can just apply and it changes your infrastructure. But you don't want that to be every time that you add a semicolon or you find a bug. That would take way too long. And when you are destroying something, right, not all resources can update in place. So some of them will need to destroy in order to then reform. And you would be affecting user experience at that point. So, more of the story is we're focusing on using Terraform to provision our resources. All right, what do we need to add? Well, we need to add all of the things that we just set up manually. So the first thing that we need to add is our private repository. You can see I deleted all of my resources, but my repository stayed, and that's because we used the console to create it. So we're going to highlight this repository, and then we're going to go ahead and click delete, and we are going to go ahead and enter delete in the field. So now we don't have this repository anymore. All right. Next, we are going to double check the next thing that we added, which should have been destroyed, but we will go ahead and check it. Nope. We're going to go to IAM because we added a policy to our IAM role. Now, we created the IAM role in our code with Terraform, so it should have deleted it, but let's just verify to be safe. You can see that I no longer have that coding with Kali EC2 role. Okay, but those are the two things that we are going to want to make changes to in our code. All right, so let's start with the IAM role because that's going to be the easiest thing. The easiest thing is that we, as you remember, is all we had to do is add another EC2 policy there. So what we should be able to do is we should be able to copy this resource, paste it below, all right, and then we should be able to change the names. So this one I'm going to change to SSM policy attachment, and then this one I'm going to say ECR read policy attachment, and then I'm going to change the policy that we use to, thank you GitHub Copilot, Amazon EC2 Container Registry read only. All right, perfect. So now when this creates my EC2 role, it's going to add these two policies. So I don't have to do anything manually for myself here. The next thing that we need to add, which we just deleted, is going to be our Elastic Container Registry. But we want to add that with Terraform. So I'm going to go ahead and type in Terraform ECR, and you will see in the docs, we can go ahead and create an ECR using Terraform. All right, so here is the example usage. So I'm going to go ahead and copy most of that. So I'm going to go down to the bottom of my code, and I'm going to add resource, AWS, ECR repository. We'll call it ECR, that's fine. The name, yep, coding with Kali, because that's our variable that we have, ECR. Let's go ahead and image tag mutability. Fine, we can make it mutable, which means that we can change the image tags. Let's go ahead. I don't really think we need to add a tag to it, but let's go ahead and say the scanning on push is true too. That's fine. All right, so now we have that. So let's go ahead and make sure we understand what our things are. So the tag mutability is set for this repository. It can be mutable or immutable, and then uh, scanning must be manually triggered. So if we scan on push, then it will scan itself. All right, so the default sounds like it's false, which is what we had when we originally set it up. And we also didn't have mutable. The default is mutable. So since the default is mutable, I'm just going to take that away. And then I'm going to honestly take this away too. Keep it simple. We don't need to scan for now. All right, so this added our ECR repository and added our IAM policy to our EC2 IAM role. So now we should be able to Terraform apply, and everything should get set up correctly for us. All right. So I'm going to go ahead and click pause here on my recording so you don't have to watch all of my resources provision. All right, everything now is provisioned, so let's go ahead and take a look. So if I refresh this page, I now see that I have a repository. Ooh, 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 ooh. All right, and I can go over to my EC2 instances, and I see that they are right there, which is beautiful. All right, but you know how I feel right now? I already feel like, oh my goodness, I don't want to go and install Docker and type all of those commands in that I've already typed in multiple times. All right. Because then I'm still going to have to go ahead and like build my image. And because I have a new ECR, so I have to build and push a new image. And then, so what we're going to do next is we are going to automate a little bit more. We're going to use the user data field to install Docker for us. Okay. And that way we don't have to worry about typing all the commands in to install Docker. We just have to worry about getting into our instances to pull down our image and get Docker running our image. Okay. So that will save us a few commands, not a ton, but enough. And it gets us to automate things a little bit better. All right. So let's go ahead and set up our user data field now. And what I'm going to try to do too is every time I change the user data field, things get really wonky in terms of like I end up having a Terraform destroy and then reapply. I've already applied my Terraform. So what I'm going to try to do is just reboot my instances after I change the user data field. After I hit Terraform apply and see if that helps. All right. So let's find our instances. So here's our instance. So we can go ahead and add our user data field back in there. And we are going to want to use file. And then let's go ahead and let's create a file. So we're not going to use script-sh anymore. We are going to let's use one called docker script.sh. Let's copy in our bin bash command here. All right. And then let's go and find, I'm going to install Docker Linux. I want to find that bookmark that I just had open in the last video. Sometimes I try to, all right, so these were the commands that worked really well for us in the past video, so we're going to try to use it. So we're going to, say yum, sure, update -y, because why not? We don't have to use sudo again because this is going to be in the user data field and we don't have to use sudo. So then we're going to say yum install docker -y. All right, and then we're going to say service docker start. And then we are going to do these commands here. So that way we can not use sudo with Docker. And this is going to allow us also to change the permissions so we can use Docker. And that should be good. All right, so this is going to make sure Docker's all ready for us to use. All right, and then we are going to use the file. So need to just write our path, which is going to be /docker-script-sh. All right, and that should be good. So now I can go ahead and Terraform apply, and then we'll see if this works with just doing Terraform apply. See, it's updating in place. Let's see if it works. And I'm going to go ahead and pause it while it's thinking, and I will resume when it's done. All right, moment of truth here. Let's go ahead and see if our user data worked here. So I'm going to just go ahead and connect via console. And so I should be able to write Docker version. This is Docker not found. So what I'm going to do is I am going to go back to my instances. I'm going to sort by running. And then I need to select these and I'm going to reboot the instances. And I'm going to let it think, and I will resume when it passes both status checks and see how we're doing. All right, so unfortunately, rebooting didn't work. So my test for adding something to the user data without destroying and reapplying did not work well. So I'm going to go ahead and Terraform destroy and apply just to make sure everything is good. All right. After destroying all my resources and then reapplying them with no changes, all right, I have now set up, you can see 2 more instances. So let's go ahead and let's connect to at least one of them. I mean, might as well both of them. All right. So that way we can see if we can connect to them and if Docker is installed for us. So we're going to say we're going to say AWS SSM start dash session dash dash target. And I hope I got it right. Paste in our target ID. And yay, we're starting a session. So now I should be able to say Docker version. And yay, we get a Docker version. So that means our user data worked out well. All right. So now, if we are following things properly, we actually need to go ahead and open up our simple API, and we're going to need to rebuild and push our repo. And the reason for that is because we destroyed our last repository in our registry. And so now we have a new one with new instructions. So we're going to go ahead and fly through these. I'll pause the recording anytime it's taking too long. I don't think we have to build again. Actually, if I build again, it should hopefully be super fast because we haven't changed anything in our code, which yay, see, everything was cached. Perfect. And then we are going to tag with the new repository, and then we will push. And this will take a little bit because we've never pushed to this repository before. So I'll go ahead and pause and then resume when it's done pushing. Still pushing, but we're almost there. All right. So we have finished pushing finally. So let's go ahead and I'm going to bring my terminal back. I'm going to go over here and get the URI, and then I'm going to say Docker pull, paste that in. Oh, my bad. I'm going to log in to AWS first. All right, so now you might notice that I'm also going to do the same commands over and over to pull my image. So you could ask, well, Callie, why didn't you use Terraform to do this? And I could add these to my Terraform user data, but then I would have a chicken or the egg situation, right? So let's say I add this login command. It's going to log in referencing my repository, but my repository is not created, and then I haven't yet when I would be creating my instance. So then you would say, well, why not put a depends on phrase in your Terraform? And I would say, okay, but then my repository would exist, but I couldn't pull from my repository because there would be nothing in it because I have to manually go run the build and push commands here in my repo to do it, right? So chicken or the egg, you could technically Terraform your ECR on its own, and then you could go build your image, and then you could add and push it to your ECR, and then you could Terraform the rest of your things, or you could just type in the commands. This will be solved with GitHub Actions anyway. All right, so now that is pulled. So now we should be able to Docker run, and we are going to run. Of course, I already forgot the command. Docker. Oh, that's all right. Yeah, this is fine. All right, Docker run dash dash rm dash p 3000 3000, and then we are going to get to my repo and get the URI, and this will then run my application. All right, so now that that is running, we will go back and take a look at our load balancer, which I'm sure you will guess is going to say that my targets are unhealthy. Um, and while we wait for the one to become healthy so we can then use our application, I am going to create a new tab and I'm going to repeat the process with my second EC2 instance. So let's go into this one. Let's copy the instance ID. We'll paste it in. Let's go to ECR to get our AWS login command. So we can log in. Perfect. And then let's go get our Docker pull. And let's pull. Go to repositories and then let's pull the latest image. And then once we have that pulled, we can go ahead and type in our Docker command to run said image. So I'm going to go ahead and pause here. Oh, you know what? We'll go and check our target group. That's something we can do while we wait. All right, still too unhealthy. So I'm going to pause until this finishes, until one or the other finishes. All right, this went ahead and finished. So now I can say docker run --rm -p 3000 and paste in the link. And now that is starting. Let's go over here and refresh. Now we have one healthy, one unhealthy, which makes sense because this one just started up. But that should be enough that are healthy in order to use our application. And yay, we have our hello world right here. All right. So now that the resources are all ready to go, we want to be able to edit our application. So what does that look like? If I want to go make a change, okay, what would I do? Well, I would make a change within my application. So maybe I want to say, hello world, how are you? All right. So I'd make a change and then I'd save it. And then I have to repeat the process that we just went over, which is build the image, tag the image, push the image. And then we'd have to go back to our instances and we'd have to pull the changes down and then rerun our Docker container with the updated image. Okay. If you're changing something small, like just what we changed here, that gets tedious. And the more that you have a manual process, the more likely that the human who's doing the manual process is going to mess up, and that's going to affect your users. All right, so we're done with this week, but next week we are going to look into how can we make a CI/CD pipeline so that way when we make changes, all we have to do is push our changes or merge our changes into main, and we will successfully deploy those changes with hopefully no downtime or very little downtime for our users. All right, see you next week.